Assalamualaikum to Madam. So this is our presentation on MAT263, the application of linear algebra. This is our group member. We have 7 group member for this project.
So next is the title of the case study, determining the perfume prices using Kramer's rule.
The introduction of case study, Mirul, Adib and Luqman wants to buy perfume from the same shop but different sizes. Mirul bought one 15 ml perfume, two 30 ml perfume and one 50 ml perfume. Moreover, Adib bought two 15 ml perfume, one 30 ml perfume and three 50 ml perfume. Finally, Luqman bought three 15 ml perfume, two 30 ml perfume and two 50 ml perfume. Adib paid for everyone first, but he forgot to take the receipt. The purpose of this case study is to determine how much each member should pay back.
Okay, so this is our problem statement. So in this case study, we face a real life situation involving the purchase of perfume from a store. So one group member paid for all 3 items, the 15 ml, the 30 ml and 50 ml perfumes. So from the same store, but we accidentally left without taking the receipt. So to avoid unfair payment and to make sure each group member pays their correct share, we applied what we learned in MAT 263, we use Kramer's rule, a method in linear algebra to calculate the price of each perfume size. Okay, so next is our purpose of study. So the main purpose of this study is to demonstrate how Kramer's rule, a mathematical method for solving system of equation, can be used in everyday life, particularly in solving real-life cost-sharing problem when exact data such as prices are unknown. By using the totals that each person paid for different item combination, we can form a system of 3 equations and apply Kramer's rule to find the actual cost of each item.
Starting for the equation, we refer back to the case study to get our 3 equations and to calculate each perfume size price. From the case study, we denote that X represents the 50 ml perfume, Y represents the 30 ml perfume, and Z represents the 50 ml. So as you can see that there are 3 different equations for each different person. Look at Mirul, he bought one 50 ml, two 30 ml, and one 50 ml. That totals up to 270. While Adib bought two 50 ml, one 30 ml, and three 50 ml size perfume, and that totals up to 420. While Luqman, he bought three 15 ml, two 30 ml size perfume, and two 50 ml size perfume, and that totals up to 440. For our methodology, we will be using Kramer's rule as stated in our case study. Find the value of different size of perfume which represent X, Y, and Z. For the first step, we will write the equation as Ax equals to B. A will be the quantity of each variable, X will be the variable, and B will be the total price. Next step, we need to find the determinant A by using the cofactor expansion as shown at the slide, which we will use the first row as a reference, which we will multiply every element of the first row with their cofactor and adding up all the product. Moving on to the working statement, we can see that we take the first row and first column and multiply by the position of the element which is positive. Then we will multiply it with the minor of the matrix that we deleted, which is left with 1, 3, 2, 2. Next, we will take the first row, only this time is the second column, and multiply it, but the position of the element this time is on the negative. That's why it is negative 1. Then we will multiply it with the minor matrix that we deleted, which is left with 2, 3, 3, 2. Then we will repeat the same step as the first one because the position is positive. This time we will use the first row with the third column. After that, we will sum up all the value that we get to determine the determinant A, which is equal to 7.
So, moving on to the next step, we will need to find determinant AX. But first, we need to substitute the B matrix value with the column S in matrix A, which is the first column. Then, we will be using cofactor expansion again with the new matrix to find determinant AX. So, we will multiply each element of the first row with their respective cofactor and adding up all the product. So for the first row and first column, we will multiply element A11, which is 270, with its minor by deleting the first row and first column to get the determinant. Next, we will multiply element A12, which is 2, with its minor by deleting the first row and second column to get its determinant. And lastly, we will multiply element A13, which is 1, with its minor by deleting the first row and third column to get its determinant. Then we sum the three determinant to get determinant AS, which equals to 280. After that, we will need to find determinant AY. Just like how we calculate determinant AX, we first need to substitute the B matrix value with the column Y instead in matrix A, which is the second column. Then we will be using cofactor expansion again with the new matrix to find determinant AY. So we will multiply each element of the first row with their respective cofactor and adding up all the product. So for the first row and first column, we will multiply element A11, which is 1, with its minor by deleting the first row and first column to get the determinant. Next, we will multiply element A12, which is 270, with its minor by deleting the first row and second column to get its determinant. And lastly, we will multiply element A13, which is 1, with its minor by deleting the first row and third column to get its determinant. Then we sum the three determinant to get determinant AY, which equals to 490.
Next, I will calculate the determinant of AZ. First, we need to write the matrix for AZ, which consists of the original coefficient, but with the Z column, it replaced by the constant value, such as the value as you can see in the screen. There is a 270, 420, and 440. Then, in that, we expand the determinant using the compactor expansion along the first row. We multiply each element by its corresponding minor and then apply the correct sign. So the calculation become one time the first minor plus 2 times the second minor with a negative sign, and then finally 270 times the third minor. After simplifying all the values, I get the final answer, which is 630. So the determinant of AZ equals to 630. And now I will find the value of x, y, and z by using the Cramer rules. For x, I divide the determinant of x by the determinant of a. That given 280 divided by 7, which is equals to 40. So for y, I do the same process, which is the determinant of ay is 490, and when I divide it by 7, the answer is 70. Finally, for z, I take the determinant of az, which is 630, and divide it by 7 also. Is given the value of z equal to 90. Therefore, the final solution are x equals to 40, y equals to 70, and z equals to 90.
So now, before we are moving to the next slide, which is the conclusion, this is the slide to verify whether the value we calculated for the x, y, and z are actually make sense. Just now, we found that the price for the 15 ml perfume is 40 ringgit, the 30 ml perfume 70 ringgit, and the 50 ml perfume is 90 ringgit. Now, using this value, we substitute them back into the original purchase made by each member. All three total match exactly with the amount stated in our problem statement. So, this confirms that the price we calculated using Cramer rule are correct and consistent. This also shows that our mathematical method will work perfectly in solving the real-life situation we were given. So, to conclude our case study, we have successfully shown how a mathematical method like Cramer rule can be applied in a real-life situation. From the start, we only had the total amount of each person paid, but we didn't know the individual price of the perfume. By forming a system of equation and solving it using a Cramer rule, we managed to determine the exact cost for each perfume size. Then, to make sure our answer were accurate, we substitute the values back into the original purchase, and all the total match are perfectly. This confirms that our calculation and method were correct. Overall, this case study proved that mathematical isn't just a theory, it's something practical that can help us solve real-world problems in a fair and systematic way. And lastly, it also shows that even simple mathematical concepts are connected to bigger ideas, from daily problem solving all the way to understanding structure and pattern in the universe. So, this is the reference that we get all the information about the linear algebra, and you guys can use it as a guidance to find many information about mathematical linear algebra and application that you can apply into a real life situation. So, thank you. That's all from us.